Hey everyone, I'm so sorry I had to miss the first class for parent-teacher conferences. So this is an answer key to the notes that you were provided with by Mr. Macklin. Normally we'll have like a more interactive lesson. Obviously I'll have a smart file, but I figured this would just be pretty easy and more efficient to show you guys kind of what's going on. So pretty much math has obviously been around forever. Math can go back to the Egyptian, the Babylonian cultures. It's been around since civilization started. And pretty much to solve like a problem, everything is a recipe. There's a template. We make observations of things taking place, and then we develop conjectures, kind of like in science class where you make like a hypothesis. So a conjecture is an educated guess based on repeated observations of a process or a pattern. This is called inductive reasoning. So we're taking specific events. If you look over to the side, the little note I wrote in, you're taking specific events and making generalizations about it. So for example, that's if it rains Monday, it rains Tuesday, it rains Wednesday, it rains Thursday, it rains Friday. You could use inductive reasoning to say that it's going to rain Saturday as well. Now, there is counter examples to this as well. Because Saturday comes around and it's not raining. So inductive reasoning it's flawed. There's no real assurance that this is actually going to take place. You can see right here, it says inductive reasoning provides a powerful method of drawing conclusions, but there is no assurance that the observed conjecture will come true. Now, the opposite of this is called deductive reasoning, where we take general facts we know and apply it to specific situations. So, for example, I know dogs are born with tails. So I have a dog named Bernie. I can assume that Bernie has a tail. Now, there is sometimes flaws, there's, maybe a dog sometime that was born without a tail. But for the most part, I know that all dogs will have a tail. So therefore, my dog Bernie has a tail too. So if we look at like natural numbers, so those are counting numbers that like kids start with. They start with 1, 1, 2, 3, 4, 5, 6, 7. We can assume that like ... means so after 3 comes 4, after 4 comes 5, and we continue on. We know this pattern. That's deductive reasoning. Actually, inductive reasoning, sorry. So if you take a look at the list of numbers, 2, 9, 16, 23, 30, they increase by 7 every time. So we can assume the next number is 37. That's inductive reasoning because we looked at specific numbers that were given to us, like the past, and we're making a generalization that every time it's going to increase by 7. But if we change the scenario and we say, well, what if we were talking about Mondays? So for example, we have Monday the 2nd, Monday the 9th, Monday the 16th, Monday the 23rd, Monday the 30th, but the next Monday is actually the 5th because there's obviously not 37 days in a calendar. So we can't always rely on inductive reasoning because there could be counterexamples and it could change based on the scenario or the word problem we're looking at. So the little acronyms that I write down and study is DGS. So deductive is general to specific, and inductive is when we have specific examples and we're making generalizations about it. There's some practice problems. I'm going to skip through them because I would like you to try them obviously on your own. So you can pause this and do that and then check your work. Now, talking about patterns, we're going to talk about different sequences. There are 2 types of sequences that we're going to take a look at. So a sequence is, having a first number, a second number, a third number, and it goes on and on. They're called terms of the sequence. So the first one we talk about is arithmetic. Arithmetic begins with an A, and a way to remember this is that you're adding or subtracting a common number every time. So if you take a look at the top with that example, we added 6 every time. And that is an arithmetic sequence. So on your test, your first test you have in a couple of weeks, I'm going to ask, what type of sequence is this? You would tell me arithmetic. I would ask you to prove it. So proving it would be like showing me these numbers underneath, +6, +6, +6, but that's enough to show your work. And then I want to know what the next term is. So the next term in this scenario was 33. So if you take a look, here's another example, 2, 4, 8, 16, 32. This is called a geometric sequence because we multiplied by 2 every time. So geometric has an M in it, which stands for multiply. That's the way I remember this. And multiplying and dividing, they're inverse operations, just like adding and subtracting. So that would also fall in a geometric sequence. So this was a test question, you would tell me it's a geometric sequence. You would show me that it multiplied by 2 each time. And then when you double 32, you get to 64, which is the next term in the sequence. So there's some practice problems. Now, it is possible to be neither. You can see that in one of the practice problems. That is an acceptable answer. Sometimes, even when it's neither, you can still find the next term, but you're just going to tell me that it doesn't have a specific name for it. Successive differences, I'm going to skip over for just a second because it's going to take up some room, and I want to talk about the sum formulas. So, sum formulas and just looking at patterns, pretty straightforward. I want you to be able to notice the pattern. So here it was 1, 1, 3, 1, 3, 5, 1, 3, 5, 7. So it was the next odd number every time. So then I have 1, 3, 5, 7, 9. Great. On the right side, I have 1 squared, 2 squared, 3 squared, 4 squared. So the next one would be 5 squared. Now, I have an underline that says verify your statement, which means to do the actual math. So I found the sum of these numbers on the left to get 25. And then I did 5 squared to get 25. These things need to equal each other. That's how you verify that you are correct. So I want to make sure you take a look at that. Now, successive differences, if you take a look at my screen, and when you go under week 1 folder, under chapter 1, there are videos about successive differences, and there's also patterns and successive differences practice that I highly recommend that you take a look at. I wanted to point those out before we go over successive differences. And also on your notes, let me pull up your notes that you guys have. You might encounter something called the sum formula. If those show up on your MyLabs Plus, it's okay. Just try your best on them. It's something we're going to talk about more in class. And I'll be honest, I'm going to end up extending your MyLabs Plus homework until a little bit after next class because I really want to be able to talk to you guys and recap on these things and not just, give you a video and call it a day. So let me go back to the key. Now, successive differences takes up some room, okay? So some sequences require more work and they're more difficult. So here's an example, 2, 6, 22, 56, 114. The first step I did is took the numbers and spread them out. And then I subtracted them. To go to 2 to 6, it's 4. 6 to 22 is 16. 22 to 56 is 34. 56 to 114 is 58. And that's where I would have stopped. Now, these numbers are not the same. The goal is to get that bottom branch to be the same number. So then I'm going to subtract these neighbors. 4 and 16 is 12. 16 is 34 is 18. 36, 58 is 24. These three numbers are still not the same. I'm going to go one more time, and I end up with 6s. Those numbers are the same. I'm going to work my way back up then. So I added another branch and wrote a 6 down. 24 and 6 is 30. So working backwards, I'm now going to combine these numbers. So 30 and 58 give me 88. And then finally, 88 and 114 give me 202. This is a long process, and this is something I really want to take time and go over in class. I do have another example. I have 2 more examples done here that I really would like you to try, but I also really want you to go to the week 1 folder on D2L and take a look at the successive differences video. I'm not going to play it now, and obviously waste your time in this video, but it's real short and sweet. It's under 3 minutes. I highly recommend you take a look at this, and it will be definitely for your benefit. So I will see you guys next Tuesday. Thank you for all your patience during this. If you have questions, the easiest way to get a hold of me is to send me a text message. I usually can get back to you in pretty decent time. My cell phone number is on almost every announcement I post. If I don't get back to you right away, give me some time. Obviously, I teach during the day, and we'll go over more introductions later on. But I just wanted to kind of fill you into this. So I hope you have a good day, and I look forward to meeting you guys next week.